So here's the video going over the Chapter 4 Part 2 review, which covers graphing trig functions and the inverse. So the first slide is already filled in since it is a graph and you're mostly just doing it on the calculator, but I'll kind of run through the important parts. So I have 3 cosine of x minus pi over 2. I want to find the amplitude, the period, and the phase shift, and I want to sketch the graph. So your amplitude is always the number in front of your trig function. So in this case, my amplitude is 3. So amplitude is 3. I'm going to go ahead and draw over this. My period is 2 pi divided by b. So anytime you're finding the period for sine or cosine, it's 2 pi divided by b, and b is the number in front of x, which in this case is 1. So that makes your period 2 pi. So that's where that comes from. Your phase shift, as long as you have a number, as long as you don't have a number in front of x, your phase shift is going to be the opposite of what you're adding or subtracting. So since I am subtracting pi over 2, my phase shift is just going to be pi over 2. Now to actually create the graph, you're given these pieces of information for your window. So in your calculator, make sure that you are in radian mode, since we always graph in radians. And your window, this is your x min, so you would hit window on the calculator, x max, x scale, and then your other set of intervals is your y min, y max, and y scale. And once you have that in the calculator, you're going to type this in to y equals, and then graph it. So I don't know if you could hear the fire alarm going off in the background, but the fire alarms just went off, and I'm sitting in school by myself. It's like 6:15, no, right now it's 6:26. So I went outside, and I was sitting outside by myself, waiting for the fire alarm to stop going off, but now I'm back. And here's the rest of the video. I just had to share that with you, just in case you heard the fire alarms in the background. Okay, so regrouping. You're graphing this in the calculator. You're typing 3 cosine of x minus pi over 2, and then you are literally copying it from the calculator to get this. You do the same thing for number 2. The only difference is with number 2, you do have this number in front of x, so we need to start by factoring it out. So you're going to factor it out of both of these. So 3x and pi over 2. So when I take out the x from 3x, that leaves me with x. The tricky part is factoring it out from pi over 2. And when you're factoring, you're essentially dividing. So I'm going to divide by 3, but dividing by 3 is the same thing as multiplying by 1/3. So if I take pi over 2 and multiply by 1/3, that gives me pi over 6. So now that I have it in this structure, I can find my phase shift. Phase shift is going to be the opposite of what you're adding or subtracting from x. Alright, amplitude's still the same, period 2 pi divided by b. B in this case is 3, so 2 pi over 3. And then graph it in the calculator, copy the graph. Alright, number 3, find the equation of the sine function in the form y equals a sine b x plus c, or y equals a sine of b times x plus c over b for the least positive value of c. I want it in this form, by the way, so you can ignore this one. So we want to find a cycle of sine. So sine looks like this. So I'm going to find one cycle of sine. So right here, there's my one full cycle of sine. And then from here, I need to find a couple things to be able to write the equation. I need the amplitude, the period, and the phase shift. Your amplitude is how high or how low your graph goes, and since my graph goes up to 2 and down to -2, my amplitude is 2. The period is the length of one full cycle. So here is your full cycle going from here to here, and that is going from -pi to 3 pi, so that distance right there represents the period, which if I look all the way across is going to be 4 pi. So the period is 4 pi. Now your period is used to solve for b. So when we were finding the period on the last couple of problems, we did 2 pi over b, so 4 pi equals 2 pi over b. I can cross multiply, so 4 pi b equals 2 pi. Divide both sides by 4 pi, so I get b equals 1/2. So I have my amplitude, I have my b, now I need to figure out the phase shift. So normally sine starts at the origin, but since there's a phase shift, it's now starting over here. So my phase shift is at negative pi. Now on your test, if it were to ask for cosine, your cosine looks like this. So going from peak to peak. So for example, from here to here, that is 1 cycle of cosine. And you would find the amplitude in the period the same way. The only difference with sine and cosine is the phase shift. Alright, so now we can write the equation. I'm going to go ahead and erase this so I have some space to write. So I have y equals 2 sine of b, which is 1/2, and then x minus my phase shift, so x minus negative pi becomes x plus pi. And then I always want you to simplify, so distribute that 1/2 into the parentheses. So I have y equals 2 sine of 1/2 x plus pi over 2. And there's your equation for number 3. For 4 and 5, you're graphing on the calculator again. It's just that you're graphing the inverse trig functions. Same thing with the windows, x min, x max, x scale, y min, y max, y scale. The difference with tangent and cotangent versus sine and cosine is the period. So instead of it being 2 pi over b, it's pi over b. Finding the phase shift is the same. This should actually be a positive pi, not a negative pi. To actually put this in the calculator, you do not have a cotangent or a secant button, but you have sine, cosine, and tangent buttons, and since these are reciprocals of your basic 3 trig functions, you can type them in as reciprocals. So this right here is y equals, and the number in front of my trig function is going to go in the numerator, so 0.5 over tangent of x minus pi. And you can put that in the calculator, and it'll give you that beautiful graph. Don't forget to copy down your asymptotes. I want to see those dashed lines and your tick marks. Same thing for the next one. Y equals, number in front of the trig function is 3, and secant is the reciprocal of cosine. So cosine of 2x plus pi over 2. Graph that in the calculator, gives you this. Couple things I want you to pay attention to. I want to see your asymptotes, and I want to see these points for accuracy. And if you'll look on the calculator, it goes up to 3 and down to -3. And that's because the number in front of your trig function is 3. So if it were a 4, it would go to 4, -4. Period is the same as sine and cosine, 2 pi over b. And phase shift, same thing. Just make sure you factor out this 2 first. And then take the opposite of that, and that is your phase shift. Alright, 6, 7, and 8, these are calculator problems. Put your calculator in degree mode. And you're going to type this into the calculator. So arc cosine is the same thing as inverse cosine. So inverse cosine of -√3, calculator's not cooperating, √3 divided by 2 is 150. In degrees, I always want your answers in radians though, so I'm going to convert that to radians by dividing it by 180, and that gives me 5/6, so 5 pi over 6. Arc sine, same thing, inverse sine of -1/2 gives me -30 degrees, but again, I want that in radians, so that is -pi over 6. Arc tangent, inverse tangent of -√3 over 3 is -30 again, which is -pi over 6. So you're using the calculator in degree mode, but you're giving me the answer in radians. So make sure you do that on the test. For numbers 9 and 10, don't just plug those in the calculator because sometimes it will not work. What you do is you use this inside trig function, the inverse, to be able to set up a triangle. So I'm going to go ahead and draw a triangle. That's why it says hint, draw a picture. So I'm going to draw a right triangle. Here's my theta. And sine is opposite over hypotenuse. Going back to good old SOHCAHTOA. So sine is opposite over hypotenuse. So that means my opposite side from theta is 3, hypotenuse is 5. And you can use the Pythagorean theorem to solve for that third side, which ends up being 4. And now that I know all 3 sides of the triangle, I can figure out what tangent is. Tangent is opposite over adjacent. So that means your answer is 3/4. Same thing for number 10. I'm going to start by drawing a picture. There's my theta. Opposite side is 5. Adjacent is 12, since tangent is opposite over adjacent. Using the Pythagorean theorem, your third side is 13. Sine is opposite over hypotenuse, so 5 over 13. All right, moving on. Solving a right triangle. So approximate the values given that C is 90 degrees, A is 33.7 degrees, and little a is 540. So again, I'm going to draw my triangle. Always helps to have a picture. C is your right angle. Doesn't matter where you put A and B. But little a is across from big A, little b across from big B, and little c across from big C. So I know A is 33.7 degrees, and side A is 540. The first thing I'm going to solve for is angle B, since I know the angles in a triangle add up to 180. So that's 180 minus 33.7 minus 90 gives me 56.3 degrees. So this is 56.3 degrees. And then from there, I'm going to solve for side B. And in order to do that, I need to figure out how these two sides relate to this angle. Well, A is the opposite of angle A, and B is the adjacent. So opposite and adjacent is going to be sine. That's not sine. Sorry. Opposite and adjacent is going to be tangent. So I have tangent of 33.7 equals 540 over B. I can cross multiply, so I get B equals 540 divided by tangent of 33.7. Going to plug that into the calculator. Gives me 809.7. So B is approximately 809.7. And then finally for C, since I now have two sides of the triangle, I can use the Pythagorean theorem. So 540 squared plus 809.7 squared equals C squared. You can solve for C. And that gives you about 973.2. Alright, for the next problem, I gave you two sides and the right angle, so I'm going to go ahead and start by drawing my triangle. There's C, A, B, right angle. I know side A is 42, side B is 68, and I don't know side C. Since I have two sides of the triangle, I can go ahead and find the third side right away using the Pythagorean theorem. So C equals 42 squared plus 68 squared. And then square root. Gives me about 79.9. So side C is 79.9. Now I'm going to figure out one of my angles. I'm going to go ahead and find angle A. I'm going to figure out how these two sides relate to this angle. So 42 is the opposite, 68 is the adjacent, so opposite and adjacent is tangent. So tangent of A equals 42 over 68. Anytime you are solving for an angle, you are always going to use the inverse. So inverse tangent of 42 over 68. Plug that in. Gives me about 31.7 degrees. So angle A is 31.7 degrees, and since all your angles in a triangle add up to 180 degrees, angle B is going to be 180 minus 31.7 minus 90, which is 58.3. Whoops. And you have now solved that right triangle. All right, next problem, word problem, everybody's favorite. So a technician is going to attach a stabilizing guy wire to the top of a radio tower. The technician knows the tower is 130 feet tall, and the wire needs to be attached at a 58-degree angle of elevation with the ground. How long is the guy wire to the nearest tenth of a foot? So here is little radio tower. I think that looks like a radio tower. We'll just pretend it is. I don't know if they have things on top, but we're just going to go with it. We know that it is 130 feet tall, so this is 130 feet. You got this guy, your technician, trying to install a guy wire to the top. This guy is, actually we don't know how far he is from it, but we do know the angle. The angle is 58 degrees. And we are trying to solve for that length. So if I look at my triangle, I have this angle, that is my opposite, this is my hypotenuse, so I can use sine. So I have sine of 58 equals 130 over x. Cross multiply, x equals 130 divided by sine of 58. Which is about 153.3 feet. All right, so the wire is about 153.3 feet long. All right, last problem. A military drone flying at an altitude of 1,500 feet is surveying two cars due north of its position. The angle of depression measured to the first car is 28 degrees, and the angle of depression measured to the second car is 84 degrees. Find the distance between the cars to the nearest tenth of a mile. So both of the cars are due north of its position, so that means both of the cars are on the same side of the drone. I don't know how to draw a drone. I'm just going to go ahead and put an X. We'll pretend that that's the drone. And we have two cars. Technically it's due north, but I'm just going to draw them over here. Car number 1 and car number 2. And we have angles of depression. So angles of depression are going from straight out and down. So we can have this angle and this angle. So you can see that one of the angles is smaller than the other. So that means your smaller angle is the one that's 28 degrees. And your larger angle is the one that is 84 degrees. And we also know that the drone has an altitude of 1,500 feet. So that means this length above the ground is 1,500 feet. So what I can do is I can start to extract out some triangles. So I have this triangle that has the 84 degrees with this height being 1,500. And I have the longer triangle with this angle being 28 degrees and your height also being 1,500. And what I'm trying to do is I'm trying to find the distance between these two cars. Well, in order to find the distance between these two cars, what I can do is I can find this entire distance, which is this side of the triangle, and I can take away this distance, which is this side of the smaller triangle. So I can find those two distances and then just subtract them. So I'm going to go ahead and call this X, and I'm going to call this one Y. So looking at my triangle, they are both right triangles, so I can go ahead and use SOHCAHTOA. I have opposite and adjacent for both of them. So I have tangent, use the wrong color. I have tangent of 84 equals 1500 over x, cross multiply, plug it in, and that gives me 157.7. Keep in mind this is in feet. And I do the same thing for the other triangle. So tangent of 28 equals 1500 over y, cross multiply, calculate, and that gives me 2,821.1 feet. So that means the distance between the cars is going to be y minus x, which is 2821.1 minus 157.7, which is 2,663.4 feet. Now, it'd be awesome if we were done with the problem, but if you look back at the question, we want this in miles, because, having it in feet is not enough. So let's change that to miles. There are 5,280 feet in a mile, so I can divide that. So dividing those two gives you about half a mile. So these two cars are about half a mile apart. All right. So that concludes the video going over the review. I hope this helps you get prepared for your test.